Hi dear students, let's see this question that came in JEE Advanced Paper 2 Physics in the year 2022. This question is from the topic of modern physics and this was a single choice correct question. So if you got this right, you get +3. If you get this wrong, you get -1. But I feel that almost everybody in India would have gotten +3 in this because very easy question. This is a very standard, very easy question. So it says that basically I'll quickly just give you the gist of the question. There is a metallic surface on which if the photons are incident of wavelength lambda, then the stopping potential is 6 volts. So using this data, we can write Hc by lambda will be is equals to work function. Phi I am calling as work function plus 6 volts is the stopping potential. So we can say that 6 electron volt will be the kinetic energy of the fastest electron. So that will be 6 electron volt becomes the maximum kinetic energy of the electrons emitted. Now it says that if the wavelength of the incident light has been made 4 times, in that case the stopping potential becomes zero point 0.6 volts. So using this data, we can write that if lambda becomes 4 lambda, of course 5 will remain unaffected, and 6 electron will become zero point 0.6 electron volt. Okay, so using these two equations, we can find the value of phi as well as uh, we can find the value of lambda as well. So first of all, what we can do is that uh, we can say that Hc by lambda. Okay, so basically Hc, if you deduct equation one, if you do equation one minus equation two. So if you do equation 1 minus equation 2, we will get 3 Hc by 4 lambda. That should be equals to 5.4 electron volt. From here, we can see that Hc by lambda comes out to be uh, 7.2 electron volts. Now, this value once substituted in the equation number 1 will give us the value phi as 1.2 electron volt. Okay, so work function comes out to be 1.2 electron volt. Hence, from the first equation again, we can say that Hc by lambda. Anyway, we have found the value of Hc by lambda. So from here, let's calculate the value of lambda from this equation. So lambda is equals to Hc upon 7.2 electron volt, right? Now, basically, if you think carefully, then they have given the value of Hc by E, which is 1.24 into 10 to the power minus 6. So H, if you put in SI units, if you put C in SI units, and if you put electron, that is, this is the electronic charge, and this is 1 volt. So this is already in SI unit, 1 volt is already in SI unit, and E is the electronic charge. So if you put the value of electronic charge in the SI unit, so we will get lambda also in SI unit, right? So we can say that this is 1.72 into 1 volt. Okay, so volt, I'm again, that will become like, that will go in the units, volts. Okay, and Hc by E ka SI value is given as 1.24 into 10 to the power minus 6. That means we can say that here it will be 1.24 into 10 to the power minus 6, right? Like this, and this unit will be joules meter per coulomb. Okay, so basically we can say that now, if you, so this unit will become meter. Okay, joules per coulomb, you know, is energy upon charge, so which is nothing but volts. So joules per coulomb will become volts. So this becomes meters, and 1.24 upon 7.2 will be 1.72 approximately, sorry, 0.172 approximately. So this will be 0.172 into 10 to the power minus 6, which makes it 1.72 into 10 to the power minus 7 meters. So option A, my dear friends, will be the correct answer for this question. A fairly easy question. Almost everybody in India would have done this. Thank you.